Alright, so here's the run through for the first handful of questions that you had asked about. Alright, number 5 to begin with is an implicit differentiation problem. So we're going to start out with our structure of taking the derivative of both sides. And we're going to take this with respect to x in this case, because they are asking for dy dx. So we'll get that written out here. Alright, now if I take the derivative, I'm going to go piece by piece. Derivative of e to the x with respect to x is just e to the x. The derivative of y with respect to x is dy dx equals, now this is a spot where there's a really common mistake. We got to remember our product rule right there. So we're going to have first d second, which is going to be 3 y squared, derivative of the outside function, evaluated at the inside, times dy dx, the derivative of the inside. Then we're going to have plus the second, and d first, derivative of x with respect to x is just 1. Alright, e to the second is a constant, so the derivative of that is 0. 18 is a constant, so the derivative of that is 0. So now I'm going to bring this over here, and I'm going to just clean it up a little bit. So I've got e to the x minus dy dx equals 3xy squared dy dx plus y cubed. Alright, now I'm going to pull things apart so I get the dy dx by itself. I'm going to move this one over, and I'm going to move that y cubed over to the other side. So I've got e to the x minus y cubed equals 3xy squared dy dx plus dy dx. I want to factor the dy dx out on the right. Alright, which leaves me with a 3xy squared plus 1. And that equals our e to the x minus y cubed. Alright, so we're going to divide, and we have dy dx equals e to the x minus y cubed over 3xy squared plus 1. Now, the question asks us for the slope at 2, 2. So dy dx at the point 2, 2, e to the second minus 2 to the third over 3 times 2 times 2 squared, which is 4, plus 1. That's e to the second minus 8 over 3 times 2, which is 6, times 4, which is 24, plus 1, which is 25. So e to the second minus 8 over 25, and that is choice C. So our correct answer on this one is choice C. Alright, now if we move on to number 6, number 6 says on a certain day, the rate at which material is deposited at a recycling center, so they're giving us a rate, alright, is modeled by R, where R is measured in tons per hour, and T is the number of hours since the center opened. Using the trapezoidal sum with 3 subintervals indicated by the data, what is the approximate tons of material deposited in the first 9 hours since open? So the first 9 hours, we're going to use all the data. So we're really looking for the integral from 0 to 9 of r of t dt, because that's going to be our accumulation of the number of tons. Area under rate is always an accumulation of the amount that was changing. So if I look at this one, it's a trapezoid rule. So area of a trapezoid is 1/2 height times base 1 plus base 2. And we're going to have 1 for 0 to 2, 1 for 2 to 7, and 1 for 7 to 9. So I'm going to have 3 of those. Alright, so now I'm going to put in my values. So I've got 1/2. The first one, the width in time, is 2. So that's going to be our height. And then to sum up the bases, we're going to take the 15 plus the 9, which is 24. Alright, if I clean that up, that piece is just a 24. Then I've got 1/2. The height on this one, it goes from 2 to 7, so the height is 5. And then I add up the bases, 9 plus 5, and that gives me 14. Half of 14 is 7. 7 times 5 is 35, so I've got a plus 35 for that piece. Then I've got this last section. It's from 7 to 9, so the height is 2. And the sum of the bases is 5 plus 4, which is 9. So that one's going to be a 9. Right, now if I push these together, I've got 24 plus 35, that's 59. 59 plus 9 is 68. And I'm going to double check. We've got from time 0 to 9, the first 9 hours. Nothing special in the problem, so we're looking at A as our correct choice. And again, on this one, the key was the trapezoid rule. All right, now the next question that you had asked about was number 8. So number 8 said, consider the geometric series from 1 to infinity of a sub n, where a sub n is greater than 0, so the positive terms. The first term of the series, a sub 1, is 48, and the third term, a sub 3, is 12. All right, which of the following statements is true about that summation? All right, so they basically give me the sum equals a certain value, the sum equals a certain value. It converges, it diverges. All right, so first of all, it's geometric. So if it's geometric, we're going to be able to determine what it converges to. All right, so this one that says converges but cannot determine, that's not going to be a possibility. Next thing, it goes from 48 to 12 and it's geometric, so it's decreasing. That means that the R value had to be less than 1, so we can't say diverges. So 2 of these are knocked out right at the get-go. All right, so what we're going to look at here is we're going to look at getting from 48 down to 12, what we're going to have to do. So from 48, I want to go to 12, and I want to take basically one step in between, because this would be a sub 1, a sub 2, and a sub 3. All right, so again, there's a lot of ways you can look at this. I kind of use number sense in problem solving. If I want to get to 12 and I'm dividing, if I divide by 2, that takes me to 24 in the middle, and then that would take me to 12 after that. All right, so again, I have basically, I'm dividing by 2, or an R value of 1/2. So now I'm going to go to my sum. Sum is first term, a sub 1, over 1 minus R. So 48 over 1 minus 1/2. That's 48 over a half, which is going to be 96. So we can say with certainty that the sum of this one is going to be answer B, which is 96. Now, there is a little bit more algebraic way of going through this one. I tend not to think of it that way, but it ends up being, I believe if I'm remembering right, we can do the geometric mean, which is going to be the square root of 48 times 12, which is going to give us a number that's in between. That'll give me the 24. All right, so this one is going to give me 24. Then that 24 fills in the gap in between, and I can figure out what it is as far as the ratio from term to term. Again, though, I really think the number sense approach of, okay, I'm going from 48, or 48, I've got 2 steps to get to 12. Half takes me to 24, half of that takes me to 12. They're not going to try and be messy with the numbers on that, so that's going to be a really safe route to go in most situations. All right, continuing on in this section, the next one that you had a question on was 10. 10 says, which of the following series can be used with a limit comparison test to determine whether the series given converges? So first thing I'm going to look at is I'm going to look at these first 2 terms. This is a lot like a 1 over n. All right, the top is a second degree, the bottom is third degree, which means it's going to behave similar to 1 over n, something where the top and bottom are 1 degree apart. All right, so if I'm going to do a comparison test, that is what I'm going to want to compare to. All right, we always want to compare to something that's easy and that we know the convergence of. And 1 over n we know diverges. So this would be our best comparison to this one, and in turn, we could show that this diverges as well. All right, if I jump through the rest, the next one was 11. All right, on 11, we have x to the 4th ln of x. And this looks like an integration by parts problem to me. So we've got our u and our dv. All right, so at first I may be thinking, let's pick x to the 4th for the u. But then over here, I'd have to take the antiderivative of ln of x, which is not easy for us. So I'm going to switch it up, and I'm going to make this one our x to the 4th. And I'm going to make this one our ln of x. And again, I did that because I know the derivative of ln of x is 1 over x. All right, we're going backwards here. I'm going to raise and divide. So I've got 1/5 x to the 5th. So now my uv is going to be 1/5 x to the 5th ln of x minus the integral of v du, which is going to be 1/5 x to the 5th times 1 over x, which would be x to the 4th dx. So I continue on with the integral. I've got 1/5 x to the 5th ln of x minus raise and divide. So I've got 1/25 x to the 5th, and we're going to be evaluating that from 1 to e. Alright, so if I plug in the e, I've got 1/5 e to the 5th ln of e minus 1/25 e to the 5th. Right, minus, and then I'm going to plug in my lower bound, which is 1. So 1/5 1 to the 5th ln of 1 minus 1/25 1 to the 5th. Alright, so I need to evaluate these now. I've got 1/5 e to the 5th times 1, right, minus 1/25 e to the 5th, minus over here, ln of 1 is 0, so this goes to 0, and I've got a negative 1 over 25. Alright, so that first piece, I'm going to go ahead and get a common denominator of 25, so I have 5 e to the 5th minus 1 e to the 5th, so 4 e to the 5th over 25, minus a negative, so plus 1/25. Now at this point I'm going to go up and look and see if I can find one that matches this, and it looks like B is equivalent algebraically, so B would be our correct answer. Now taking a look, rest of the section, I think that might have been the last one in this group that you had a question on. So I hope that answers the questions for this first group. I'll get the second group of questions out to you tomorrow. It's already a little late for me right now, so I don't think I'm going to get it done today. This is posted in your OneNote notebook, and it is in your class notes section. So if you want to see the worked out solutions and the worked out problems and check them, they're there. I'll also send you a link of the video and include it on that page at the top as well. Hope that was helpful. Thanks, bye.